Hello, I'm JIALONG WU, and today I want to present my individual project on solving a constraint optimization problem using the KKT. The goal is to minimize the objective function subject to these three constraints. First one, we should formulate the Lagrangian function according to the objective function and these three constraints. And one thing we should keep in mind is number 1, 2, 3, they are all greater than 0 or equal to 0, because in KKT condition, the Lagrangian multipliers associated with inequality constraints must be non-negative. And then we should consider the KKT necessary conditions. There are 4 conditions. The first condition is stationarity. We should calculate the FOC for x and y and set the partial derivative of the Lagrangian to 0. And the second condition is primal feasibility. All these constraints must be satisfied. Part C, just like we said before, lambda 1, 2, 3, they are all greater than 0 or equal to 0. And part D is complementary slackness. Lambda 1, 2, 3 multiplied by these constraints must be equal to 0. And then we should solve the KKT conditions. Case 1, we assume that number 1, number 2, number 3, they are all equal to 0. And according to its stationarity and primal feasibility, we can get a candidate solution and objective value. Case 2, we assume that number 1 is greater than 0. Number 2 and number 3, they are both equal to 0. According to its stationarity, we can know the candidate solutions and objective values. And for some other cases, we don't talk about other single constraints and multiple constraints because of time limit and complexity. We assume that all these points are here, and we just need to verify the optimality later. And then we should evaluate these candidates. It's clearer that the most negative value is -5 and 0.10. And then we should use second order conditions to verify the optimality. For the 0.10, we should set the tangent space. And then we should calculate the Hessian of Lagrangian. And restricted to the tangent space, we can know the Hessian is positive definitely on the tangent space. So it's clear that the 0.10 is the strict no-code minimum. And then I use R to visualize the optimization problem. And we can know that the gray part is the feasible set divided by the constraints, and other parts is the level curves of the objective function. And we can know the point 10 is clearer than the point 10 is on the boundary of the curve. So we can know then is the strict local minimum. So we can know the final answer. The optimal value of the objective function is -5 and 0.10. So this is my individual project. Thanks for listening.